Okay, so this is 4.2a in college algebra, combining functions and composite functions. And combining functions is basically, if you look at the top of page 263 in the green, it gives you the sum, difference, product, and quotient of functions. And what that table looks like is sometimes they will give you an f of x and say that's equal to x cubed, and then they'll give you a g of x and say that's equal to x minus 1. And what they'll ask you to do is add those two. So when they say add those two, what they'll do is they'll say f plus g in parentheses of x. And what that means is we take the f part of it, then we take the g part of it, and we add those up. Okay? And we get that for an answer. Alright, sometimes they'll say subtract the two, and this is a formal way of writing that. And what that means is the f part minus the g part. Now look what happened here. I put it in parentheses because I'm subtracting this whole thing, which means then we've got x cubed minus x plus 1 when you distribute that negative all the way through. And then the next one is they may have f times g and x, and then they've got, of course, the x cubed times x minus 1, and you'd get x to the 4th minus x cubed for an answer. Alright, the final one they'll give you is, okay, let's see if I can get rid of some of this so that I'm not moving stuff out of the way. Alright, the final one they'll do is a division, and they'll do again in parentheses f over g of x, and that will equal x cubed over g of x, which is x minus 1. Now, one of the things they are specific on, that they don't have to be here, is the denominator, okay? Because the denominator cannot equal 0, or the whole thing is undefined. So when you get a fraction or you get a division like that, you write it like I have there, and then you say all real numbers, that this thing there is my symbol for real numbers, except 1. Because if x is 1, 1 minus 1 is 0. So whenever they ask you for the domain, what are the possible values for x? And you've got a division here, it would be all numbers except 1. Now this one would be all real numbers, not even a problem. But here it's all real numbers except 1, because that would give us a problem. Okay, so that's the operation with functions. In fact, we just did example 1 showing you how to do that. Alright, so I'm going to skip example 2, and no, maybe I won't skip example 2. I know you wish I would, but anyway, the demand for a certain electronic component is given by the formula P of x equals 1,000 minus 2x. Okay? And x is the number of components that we're selling. Alright, so it costs us $19.99 for setup fees, etc., and a production cost of $4 per component. Alright, they give all that here. Write the equations that model total revenue and total cost. Okay, so total revenue would be R of x equals P of x times how many we sell. So that would be 1,000 minus 2x times x, which would be 2x squared and 1,000x. All right, so that would be our revenue. Our cost, on the other hand, would be, I need to change colors. Sometimes that green is too hard to see. Cost, on the other hand, is going to be $4 times how many we produce, plus that $19.99 fee that we had talked about earlier, setup fee. Okay. Next question, B. Write the equation that models the profit as a function of the components, I don't even know how to say that, produced and sold during a month. So, our profit is going to be our revenue minus our cost, or this minus this. So let me go ahead and write that with the numbers there. So we've got 1,000x minus 2x squared minus c of x, 4x plus 1999. Remember to put these in parentheses because that negative is going to affect things when I take off that parenthesis. Okay, and that's my profit. Okay, so you're going to go ahead and do the work, and you're going to come up with, when you simplify, you're not coming up with an answer, you're just coming up with a simplification. So I couldn't combine anything with there. I could combine the 1000x with the 4x, and can't do anything with the 1999. Okay, so this is my A, this is my B, and this is my C. And you'll understand why I did that in just a minute. Find the maximum possible monthly profit. Now, if you remember from parabolas, it is written in the formula ax squared plus bx plus c. So that's why I said A, B, and C right there. Okay, and they're asking for the maximum monthly profit. So that is given one of these. Where is the maximum monthly profit? And the reason I know that that's upside down, downward, is because of that minus sign. So I'm looking for this number here, and if you remember, that vertex, or the x value of the vertex, or the axis of symmetry, uses the formula negative b over 2a. I find that, and I'm going to find the x part of this max here, which is what I'm looking for, the maximum profit. So I'm going to find the x. The y is the maximum profit. So I'm going to find the x. So using this formula, I end up getting negative 996 over 2 times negative 2, which ends up giving me 249. So that is my x value. Now to find my y value, this distance, which is the monthly profit, I'm going to have to take that 249, plug it back into here, and I end up with an answer of, and I'm not going to graph this, 122,003 smackaroonies. Okay, so anyway, that's example 2. C, they don't even explain in part C where we even get this formula. They just have it. So remember, that part right there is where it's going to come from. All right, so I'm going to go ahead and skip example 3, and we're going to go to example 4 and talk about average cost here just for a minute, and then have lots more fun later. Okay, so the company's average cost is when a certain number of units are produced, which in this case, in the book so far, we've used X as that. So the problem says when X units are produced, the average cost is the quotient of the function C of X, which is the total production cost. So this is C of X is the cost, And the identity function, I of x, which basically is x. Okay, so the average cost, and just to go over this line here, over a capital letter means, it doesn't matter if that's an A, B, C, D, doesn't matter, but since we're talking about cost, we're going to use C. That line over there means the mean or the average. In fact, you should have a button on your calculator that has to do with statistics that has a line over it like that. And that's what that line means, is if you want to take the average or the mean real quick, you can do that. Okay, so anyway, here's our formula. I'm going to rewrite it here again in black. Bottom of page 265. The average of the cost is the cost divided by the number that we've sold. Okay? So, I'm going to use that, get rid of everything else here. Alright, so Sonny's greenhouse. Sorry about all this. I'm trying to get rid of some of this stuff here. There we go. Sonny's greenhouse produces roses, and their total cost for the production of X hundred is. Okay, so this is the cost. This is C of X. So it's going to go up here eventually. Is 50X plus 500. Alright, form the average cost function. The average cost function uses that. We're just going to put some numbers in there. It's going to look like that. Okay, not anything weird going on there. Alright, so for which input values is C defined? Well, obviously that would be anytime the number of roses sold is greater than 0, because you're not going to make any money. There's no average. There's nothing if x is 0 or if x is a negative number, because it won't be a negative number. Number 1, because if this is 0, it's undefined. And number 2, you're not going to produce a negative amount of roses. All right, so C, graph, and they've got the graph there. Okay, so bringing us to the next section, and I think we can get done with this in 2 videos. We'll see. So anyway, that's it for 4.2a. The next one will be 4.2b.